Next, we'll introduce concepts specific to Google Kubernetes Engine. That diagram of the Kubernetes control plane had a lot of components, didn't it? Setting up a Kubernetes cluster by hand is tons of work. Fortunately, there's an open source command called kubeadm that can automate much of the initial setup of a cluster. But if a node fails or needs maintenance, a human administrator has to respond manually. I suspect you can see why a lot of people like the idea of a managed service for Kubernetes. You may be wondering how that picture we just saw differs for GKE. Well, here it is. From the user's perspective, it's a lot simpler. GKE manages all the control plane components for us. It still exposes an IP address to which we send all of our Kubernetes API requests. But GKE takes responsibility for provisioning and managing all the master infrastructure behind it. It also abstracts away having a separate master. The responsibilities of the master are absorbed by GCP, and you are not separately billed for your master. Now let's talk about nodes. In any Kubernetes environment, nodes are created externally by cluster administrators, not by Kubernetes itself. GKE automates this process for you. It launches Compute Engine virtual machine instances and registers them as nodes. You can manage node settings directly from the GCP console. You pay per hour of life of your nodes, not counting the master. Because nodes run on Compute Engine, you choose your node machine type when you create your cluster. By default, the node machine type is N1 Standard 1, which provides one virtual CPU and 3.75 gigabytes of memory. Google Cloud offers a wide variety of Compute Engine options. At the time this video was made, the generally available maximum was 96 virtual CPU cores. That's a moderately big virtual machine. You can customize your node's number of cores and their memory capacity. You can select a CPU platform. You can choose a baseline minimum CPU platform for the nodes or node pool. This allows you to improve node performance. GKE will never use a platform that is older than the CPU platform you specify. And if it picks a newer platform, the cost will be the same as the specified platform. You can also select multiple node machine types by creating multiple node pools. A node pool is a subset of nodes within a cluster that share a configuration, such as their amount of memory or their CPU generation. Node pools also provide an easy way to ensure that workloads run on the right hardware within your cluster. You just label them with the desired node pool. By the way, node pools are a GKE feature rather than a Kubernetes feature. You can build an analogous mechanism within open source Kubernetes, but you would have to maintain it yourself. You can enable automatic node upgrades, automatic node repairs, and cluster autoscaling at this node pool level. Here's a word of caution. Some of each node's CPU and memory are needed to run the GKE and Kubernetes components that let it work as part of your cluster. So, for example, if you allocate nodes with 15 gigabytes of memory, not quite all of that 15 gigabytes will be available for use by pods. This module has a documentation link that explains how much CPU and memory are reserved. By default, a cluster launches in a single GCP compute zone with 3 identical nodes, all in one node pool. The number of nodes can be changed during or after the creation of the cluster. Adding more nodes and deploying multiple replicas of an application will improve an application's availability, but only up to a point. What happens if the entire compute zone goes down? You can address this concern by using a GKE regional cluster. Regional clusters have a single API endpoint for the cluster. However, its masters and nodes are spread out across multiple Compute Engine zones within a region. Regional clusters ensure that the availability of the application is maintained across multiple zones in a single region. In addition, the availability of the master is also maintained so that both the application and management functionality can withstand the loss of one or more, but not all, zones. By default, a regional cluster is spread across 3 zones, each containing 1 master and 3 nodes. These numbers can be increased or decreased. For example, if you have 5 nodes in Zone 1, you will have exactly the same number of nodes in each of the other zones, for a total of 15 nodes. Once you build a zonal cluster, you can't convert it into a regional cluster, or vice versa. Regional and zonal GKE clusters can also be set up as a private cluster. The entire cluster, that is the master and its nodes, are hidden from the public internet. Cluster masters can be accessed by Google Cloud products, such as Stackdriver, through an internal IP address. They can also be accessed by authorized networks through an external IP address. Authorized networks are basically IP address ranges that are trusted to access the master. In addition, nodes can have limited outbound access through private Google Access, which allows them to communicate with other GCP services. For example, nodes can pull container images from Google Container Registry without needing external IP addresses. The topic of private clusters is discussed in more detail in another module in this specialization.